Welcome everybody to this week's Azure and AI Show. And we hope to have two speakers with us today, but we have Naveen Kumar. He's here with us with his session on agentic AI workflows for healthcare claims processing. And we hope to have Hamasri. She's doing a session on real-time payment systems, platform engineering for instant transactions. And I'm just going, and we've got Hal Holster. He's with us here from the US. Hal is in Arizona. Naveen, you're in California, and myself, Frank Falvey, here in Cork in Ireland. So I have your slides on the screen there. So Naveen, if you want to carry on.
Yeah.
Yeah, your slides are just gone again. I'll just share them again.
Yes. Okay. Are you able to see my screen?
Yeah, I can see your screen now. Yeah.
Hello, everyone. Yeah. Let me know if you are able to see my screen. I'll start.
Yeah, I can see your screen there now. Yeah, perfect.
Yeah. Hello, everybody. I'm Naveen Kumar Poppala. I'm working as a lead software engineer in USA in Fortune 500 companies called Optum, part of United Health Group. Today, I'll walk you through the session on agentic AI agentic or AI agentic enterprise workflow system. How the agentic AI is transforming the enterprise workflows with the help of example healthcare revenue cycle. Yeah. So here is our 30 minutes agenda. We will start with the problem and then I will show you the zero touch architecture, how the agentic AI helps healthcare industry in processing the claims. So the workshop agenda is the $265 billion claim crisis and why is sorry.
No, you're grand. Carry on.
No, can I go ahead?
Yeah, carry on. Yeah.
Yeah. So the $265 billion crisis problem and why agentic AI, not just RPA. And I will deep dive to the zero touch architecture and agentic design patterns and proven guardrails and complaints and roadmap and return on investment. And end of the session, we'll have a Q&A. So let's start with the problem statement. Every year, the USA healthcare system wastes almost $265 billion annually on claims administration alone. So if you look at the slide, the initial denial rate itself, the 11.8%, and 41% providers with a denial rate about 10%. And shockingly, still the 50% providers still review claims manually, and only 14% are using AI for claims. In that 14%, we are seeing 69% having very fewer denials. That means almost close to 70% is the success rate. And before I jump into the deep dive, I want to introduce two parties here in the healthcare industry. One is payer, one is um, one is provider. So payer is nothing but the insurances companies who does the claim processing, all this stuff, and providers are nothing but hospitals and um, doctors who submit the claims. Yeah. And okay, so before going to the architecture, and we will see why the claims are failing. And if you look at the current slide, there are different categories. eligibility, registration errors, missing prior authorization errors, coding and documentation errors, medical necessity disputes, and duplicates and timing issues. I'll just give you a small examples on each category so that you will understand on what basis these claims are failing. Eligibility registration errors are nothing but if the when the provider means hospital or doctor is submitting a claim, so he might miss the enter the wrong member id or insurance details or expired plan coverage. So these comes under eligibility or registration errors. And coming to prior auth prior auth authorization, right? So sometimes if the provider is doing a tough or complex procedure, so he has to take some prior approvals. That is what it is missing, and because of that these claims are also failing, and that category is 22%. And coding and documentation errors, nothing but there are some standard codes in healthcare industry to diagnose the problem, like ICT, international classification of diagnosis, or yeah, and CPT, current procedural terminal codes. These are standards across the healthcare industry, and these codes should be there in claims, and some might be updated or so in the submission process they enter the old codes, and those comes under coding and documentation errors, and those are 20% as you seen in the slide. And medical necessity disputes and duplicates are comes under 18 and 14%. So these are the very basic errors. So with but still it still the denials are very high percentage. So we will see how these can be fixed using the agentic AI, and that's what we are going to deep dive in the next couple of minutes. And before going to the agentic AI, so why agentic AI, not just RPA? So RPA is nothing but robotic processing automation, and rules engines have been around in healthcare for years. They work simple for the repetitive task, and when they break, if something unexpected happens, so they break. But agentic AI does not automate steps like RPA. It reasons across the entire claims life cycles, and it adapts to shifting payer behaviors. So itself, okay, yeah, it self corrects the real time when it sees a denial pattern emerging. Yeah. Coming to the what makes AI agentic. These are the four pillars in AI agentic. One is goal oriented, one is autonomous decision making, and self correcting and guardrailed. So if you look at these four pillars, so the first one, the goal oriented, is nothing but agent pursue defined objectives like maximizing first pass rate itself, not just executing the scripts. And second one, autonomous decision making, they reason through multi-step workflows and handle exceptions without waiting for the human. Third, the self-correcting, they learn from denial patterns and payer feedback to improve the future submissions. And this is most important also, the guardrailed one, because in most of the financial and healthcare industries, the data is very sensitive, and thus the critical for they need to apply the compliance, uh, they need to operate within the strict compliance boundaries, so like HIPAA state regulations and payer specific rules. So this is the one, it makes these four pillars makes the AI agentic. And if you look at here, agentic versus traditional architecture, let me show you the contrast side by slide here. Traditional architecture is monolithic, like on it is a one pipeline, one failure cascades through the whole system, and rules are hard coded, and manual exception queues, and no learning loops, right? Whereas agentic AI, distributed agents, failures, I mean, it learns failures stay isolated. It won't impact the entire system. It's self-updating the pair policies. If the new policies are updated, agentic AI learn those policies and autonomously reasoning and real-time event-driven processing and continuously learning from the EHR and EMR systems and with along with the payer policy systems. I'll take a pause here. If you have any questions so far before going to the deep dive, I'll take a pause and
I don't have anything coming in on the chat from this side here. Hal, do you have any questions? You're on mute.
but I can read your lip movement.
Sorry about that. Yeah, no questions so far. Great demo. Or presentation. Keep going.
Thank you. So this is the zero touch architecture where the clients can process from end to end. So as I mentioned, the payers should follow this zero touch architecture to process the submit the claims. Sorry, not payers, providers. Uh, Before submitting the claim, if they follow this zero touch architecture in their organizations, definitely the claims get more successful rate. And if you see here, this is a core architecture, and we'll spend most of the moment here, and then we'll go to the each agent in detail. The event comes to the event bus, where it's a like a we can say like a table, if you understand in high level, or event bus. So the eligibility agent always look at that event bus, and based on the event type, it picks up the claim and it checks, hey, is this claim is having all the eligibility R and registration details, and if these are the details are correct, um, and if it is not there, it will update and it will post a new event in the event bus. Then coding validator will look at the event bus, and based on the event type, it will pick up and check, okay, is that coding all the information is correct or not, like ICD codes and 10 CPT codes. As I mentioned, these are the standard codes. It look at that details and post a new event back to the event bus. Then prior auth agent comes to the picture. Prior auth agent will check the event bus again. Okay, if the event type is prior authorization, then check the claim details. Okay, this claim is having taken the prior author approval for this complex procedure, because assume the claim is having a complex procedure and is okay, it is not there. Let's resubmit this claim back. That means it will it will send a API call to um, prior prior authorization approval, and then once the like it's a continuous process until prior auth agent reaches its goal. Okay, it does the learning process, it will apply reasoning and do the analyzing process, and it will apply that rules, and finally post back to the event bus. And before going to the submission agent, then okay, then the three agents, all these agents will work in isolated environments. That means it won't dependent on uh, each output of other agents. So it will simply look at the event bus and it will start their work. That's why I mentioned these agents works in isolated environment here. And finally, the confidence score will be uh, decided by these three agents, and submission agent check the confidence score Okay, this claim confidence score is good, like greater than 70% or 80%. Let's submit. If it is a some threshold less than this threshold, yeah, it's required some manual approvals. And no, it is very less approval confidence score. Yeah, it escalates to the human. Hey, because this confidence score of this claim is very very low. You need to take a look, because we are not oversighting the human. The human approval is very important in each phase, and that is the reason the confidence score plays a key role here. And finally, the submission agent submit the claim, and the denial triage agent comes to the picture if the claim is denied by the payer, and look at the details, and if correction is needed, it will push back to the event bus. Then this process will loop. And coming to the appeal agent, if there no correction is required, it is required only enhancements or some proofs. So the appeal agent will submit the claim with that proofs to the payer. And provenance graph um, play important role here. The provenance graph, what exactly, like, it captures every log on each stage, and captures in the audit log system, because what data used and what is the output and what decision made, everything should be captured in the provenance graph. And finally, the policy engine will contains all the policies uh, defined by HIPAA and data sources like electronic health records and electronic medical record systems. So this is the zero touch architecture, and maybe I'll just go through each agent little more deep dive in the next slides.
Yeah.
So
So we just have one question coming in from YouTube. I'll just put it up on the screen and I'll call it out to you. Yeah. So, what's the next best thing better than cloud storage? Don't know if that's related to your thing, but
yeah. What is the next best thing better than cloud storage? I think with my experience, the cloud storage is the most to deploy agents or run the agents or agentic AI, right? So you need a lot of infra, and for that infra, I think creating manually, like in a isolated environment by organizations, is very difficult. So the cloud storage is very important. And I think I don't see any alternative option right now better than cloud storage. So we need to align with the AWS or Azure or GCP clouds. I hope I answered your question.
okay, I'll tell you if we get a reply, so you can carry on there. So, thank you.
So coming to the event-driven claim flow, right? As I mentioned, I'm talking on the example of healthcare industry, how the agentic AI changes the enterprise workflow systems. So I took the example of the claims processing example, and how that can be, because the claims is the most tedious and the most toughest process in the healthcare. Yeah. So coming to the event driven claim flow, as I mentioned in the previous slide, the claims event, this is a event driven system. Claims received, eligibility check in the event bus, the same thing, coding validation checks the against the event bus. So all these are event driven, so that it will be because of the event driven system, the benefits are asynchronous communication. That means agent communicates via event. It does not talk directly. And if one agent is slowed down, the other agent won't impact at all, because of the event driven. And idempotent processing, every agent is can safely run and failed events. Finally, observable by design. every event carries a correlation ID so that we can have a full log auditability in the distributed trace from intake to submission. And this is the eligibility agent deep dive system. This addresses 26% of all denials, the single largest category. As I mentioned previously in the very starting of the slide, 26% denials comes from the eligibility. So that is the reason this agent plays a major role in the claim submission process, and it does the real-time verification via payer APIs using the 270 and 271. So there is a APIs defined in the healthcare industry for electronic data inter exchange, that is 270 and 271. So it checks, okay, this eligibility pay verification is through these APIs, and it cross reference patient demographics with payer records, and because every patient information is stored in the payers payer mm, data store. So it cross checks before submit the claim and validate the coverage dates, plan type, and benefit details. If flag mismatches before the claim submission, then it makes the agentic. That means it does not just check the why it is failed, why it is not mismatching. It reasons, like each step it calls the API and checks the details, and it checks the payer information, and it learns from the common payer rejections. So, and finally correction, it will apply the corrections, and finally this can save 40 to 60% reductions in eligibility related denials. This agent plays a very important role. And I mentioned, like, after the eligibility agent there is a coding validator, and so coding validator is nothing but I am repeating again so that everyone will understand. In healthcare industry especially, there are ICD and CPT codes. So these are the very standard diagnosis codes and procedure codes. So all this information should be um, valid in the claim submission by the provider before goes to the payer. That's the, so sometimes the codes might be updated or obsoleted, so the new code comes to the picture. But because of if you do manually, if the provider does manually submitting the claims, if they don't have the information, the updated information, the claims fail. But whereas the coding validator check that information up to date, and sub against to the submitted claim, and if required it corrects that and submit a claim. And finally, denial and triage agent and appeal agent. As I mentioned, if the denial comes, it will goes through the what are the root causes, and it will resubmit the event back, and finally the loop start from the beginning and update the corrections and submit the claim. In order to, like, coming to the appeal agent, right? If the claim is read some additional information, it will resubmit the claim that with the reappeal the to the payer with the additional information. So if you remember the zero touch architecture dive, the slide, so along with the agent, the orchestration layer is the main and the center plays the key role. And I mentioned event bus, confidence router, provenance graph, and the policy engine. Here event bus is nothing but, like, it's a event driven system. That means there are the top rated technologies like Apache Kafka, AWS Event Bridge, and Azure Azure systems, Azure bus, and all this information comes to the pitch in the event bus. And the confidence router, machine learning based scoring will be decided based on the in the claims and agent assisted. And provenance graph, it's a DAG based audit trail tracking, so it captures everything in the provenance graph. And finally, policy engine, so it contains all the rules repository, like state regulations and payer specific contract terms and HIPAA. So agents always learn from these policy engines, so that if anything needed or updated required in the claim, it will update based on the learning. And as I mentioned, confidence based scoring is important one before submitting a claim in the healthcare industry, because the confidence score plays very important role. And if the high confidence, and if it requires very low complex, it and got, we put the threshold of 65 percentage. So low complexity, like there is no human required. And um, with 25 percentage, here the human medium and low confidence scores, the human will be required for the reviewing the claim and approving the claim. And prevents and audit trails, as I mentioned, in each stage, what, okay, the agent before take the decision or updating the claim or analyzing the claim, what data is used and what data is ingested and what rules are applied, how the decision made, confidence score, how it was confidence score given by all these agents, and what is the final outcome, everything, like from each minute details will be captured in the prevents and audit trials. And these are the technology stacks we used. And one is LangChain and LangGraph. And we used a few models, GPT-4 and GPT text model, like text to vector embedding models, and orchestration layers, as I mentioned, Kafka, um, and data layers, 270 and 271. These are the APIs we called. And vector stores, we used earlier we started with our proof of concept with the ESPA in the local, then we shifted to Azure AI service. And finally, we, for the observability, we used open telemetry and Datadog. So these are the technology stacks. And I'll take a little pause on any questions so far.
No, just that guy that asked about the cloud storage. He's okay with that answer anyway. Anybody else have any questions? We have some people joined us from the June team conference. So hello to everyone there. So no, Naveen, no questions.
Okay, I'll move forward. So failure handling in agentic systems is also very important topic. That is the reason I added this slide. And so what happens and when things goes wrong, right? So for failures handling patterns, retry with the exponential backoff and jitter for transient failures like API timeouts and rate limits. So agent will take a pause and retry after some time. Like sometimes API limits, timeouts and rate limits comes to the picture when we are calling LLM API calls. That's where the agents will take a pause and it will retry after some time. And coming to the dead letter queue, so failed events, right, after max retries go to the dead letter queue. So that means, okay, agents are keep on trying, but still there is no output or there is no luck. Then finally it writes to the events to the dead letter queue. And we establish a system, okay, in every 24 hours, whatever the events there in dead letter queue, that will be resubmitted back to the main queue, uh, using our Azure functions. So the Azure functions, every 24 hours, it captures all the events, whatever the field events after a couple of retries, it captures those events and put it back to the main queue by Azure functions. And circuit breaker and this dead letter queue, so that what is the goal, right? When we write the dead letter queue, so we won't miss, even though after a couple of retries, if the event got failed, we won't miss it. We will retry, we will add it to the dead letter queue, and we will resubmit back. That's how, if the from the main queue, if the event got failed, and after a couple of retries, we are writing back to the dead letter queue, and if the dead letter queue got failed, sorry, after 24 hours, we will read all the events from the dead letter queue. That's how we can get the fault tolerance. And the circuit breaker and graceful degradation. If any external API is consistently failing, circuit breaker prevents that cascading failures across the agents. So that is the important of circuit breaker. And the graceful degradation, if one agent is down, others will continue. So if the claim skip the unavailable step and get flagged or flagged for reprocessing later. So other agents won't go down at all. And HIPAA complaints, I'll just mention very high level on this, because these are the healthcare compliance, and we need to, the agent should follow. So PHI minimization, before the agent sends any information to the LLM, the data should be masked. And because the PHI data, personal healthcare identification data, is very sensitive, it contains SSN, their names and addresses. So that information and health PI data and PHI data should be minimized or masked before sending it to the LLM on the decision point. And state AI laws, every state have their own AI specific regulations. So the AI should follow that. Human should be always in the center, so that any decision should, the complex decision before goes to the payer, should be reviewed by human. And audit, as I mentioned, we need to capture every minute details in the audit retention. And these are the phases we implemented. So first phase, as example, like eligibility, coding agent, and auditing logging. Then we did expansion 4 to 6 months, prior auth, and autonomy appeals generation, payer behavior modeling, and finally full intelligence from zero touch for clean claims continuation. So these are the return on investment, projected return on investment. In the first pass rate, the claims before agentic AI, it is 72% failure. After agentic AI, it is 94%, and the denial rate come from 12% to 4, and days in AR 45 to 18, and cost per claim to $8 from 25 to. So these are the scenarios we gone through so far. Claim intake, eligibility check, prior auth, like when the claim intake submitted, the eligibility comes to the picture, prior authorization. Okay, this claim required some prior authorization because it is involved with some complex procedure, and then comes to the coding validation. Finally, based on the confidence score, if it is greater than 0.8, then submission will happen. So challenges and lesson learned. So data quality is the most important. So that's the reason EHR data is messy. So we need to make sure build robust data before building these systems. So the data should be cleaned and transformed and follow the governance. So that data quality is very important, because the LLMs will take a decision based on the data. And change management, clinicians and billing staff must trust that system, and with the human in the loop. That is very important. In any agentic AI world, the human in the loop is very important. And guardrails, right? Guardrails, you need to define, hey, you should not cross boundary these rules. So we should not go beyond these rules. The guardrails and human in the loop is very important. And LLM hallucinations, LLM, like, if you ask any question, it will provide the answer. But if you put some threshold and temperature, all these parameters, the hallucination will be low, so that the output won't be biased. And payer variability, we need to learn, because each payer has their different rules. So we need to uh, integrate their APIs into our systems, so that the agents will call the APIs using the uh, tool systems, and finally update the uh, corrections. So these are the key takeaways. So the claim crisis is accelerating, and don't want $260 billion is wasted. Is not a normal thing. It's a huge cost involved. And agentic AI goes beyond RPA. As I mentioned, robotic processing automation, it won't go beyond some certain defined rules. But agentic AI goes that adopts, self-corrects, and learns from the mistakes and apply in the next claim life cycles. Architecture matters, because event driven, because agent should be worked in isolation environment. The event driven is very important. And compliance is the first design, because sensitive data should not be exposed to um, LLMs and agents. So where the data should be masked and follow all the state regulations, AI regulations, and compliance. Yeah, these are the start now, like phase one, and delivering return on investment in months. Yeah, any questions? That's it from my end.
Okay, great presentation. You covered it well. Um, just one question there for me. You know, on the ROI, I know your company now is different, but how much do companies have to spend on this?
Are you talking about the time, or
Return of investment. How much investment do they need to put into to set up this system?
so as I mentioned, right, the first pass rate itself, uh, 72 to 90, 94 percentage, right? That is the projected investment output.
Okay, so it varies on the size of the company that's using it.
Yes.
Okay, okay.
But
Any
most of the time, right, the providers who submit the claims, when they use this zero touch architecture processing, uh, most of the basic errors they can immediately solve it. Like their success rate, right? When they, okay, let's say few providers having very basic denials. So, hey, this claim is denied based on the expired coverage you mentioned, but that will be automatically corrected by agents, so that the return on investment is very high in that cases. And let's say if other providers get an coding errors, like they don't have proper or payer or the patient informations, right? Sometimes they're not, they doesn't have updated informations. But in that case, if you take the coding errors, right, it calls directly the insurance company APIs and get the information, and before submitting the claim it will update the claims, correct the claims, so that in that cases the return on investment is very high as well.
Okay. So you've got another question in there from, I'm not sure if it's, I'll just put it up on the screen there. I'll just hide your one there for a second and I'll put it up on the screen so you can see. Can you see that?
Yeah. So good question. Agentic AI is definitely a dangerous if you don't define guardrails for your system. That and if you don't involve in the human in the loop, right? So every agent should have that limitations. Hey, you should not cross these limitations. If you cross, definitely if you don't define it, then yes, the agentic AI is very dangerous. But you can reduce that um, impact of that goes beyond, right? Like the agents, if you don't define that guardrails, it will have a lot of impact. That is the reason human in the loop guardrails on each agent, what are the boundaries, defining the boundaries. So that is very important in order to achieve our productivity with in the governance side.
Okay. Any other questions? No, we're good. Hello to everybody in Chicago. You're on mute. Hello, can you hear us in Chicago? No.
That's in Soka P. Maybe need to be the one to do the unmuting.
Yeah, it's great presentation, Naveen, on the agentic stuff. Yeah, great to see. Stuff is starting to work already. Yeah, companies are using it. Yeah.
Thank you. Have a great day, guys. Bye bye.
Okay, thanks for joining us, and
Thanks, Naveen.
Thank you. Thank you all.
come back again when you have some more new stuff for us. Give me
Yeah,
a
yeah,
shout.
sure.
We'll have-
I will submit it in
yeah,
the.
yeah. So you have you're copied on. Are we connected on LinkedIn?
No, I don't think so.
Yeah,
But I'll send the request.
I'll copy you on LinkedIn, and sure we'll talk again going forward. Thank you.
Thank you.
Hi Dan. Hello to everyone in Chicago.
Yeah. Thank you, guys. Bye.
Okay. Thanks, Naveen.
Hey,
Hey, everybody.
yay! Dan's here.
We are here at the Juneteenth conference,
How is that going?
and this is on the Teams meeting, right? Okay. Let me get into our Teams meeting. This is Carol, by the way, everybody.
How you doing, Carol?
Everyone. Frank, Al, and Mirren. Let me see if I can get logged into my Teams here. Hold on one second.
Many companies, it was during .com boom, bubble burst. So I agreed to send this
Well, Carol,
I made one for my son's basketball team and called it, I forget the front team's name was, but it was like VMA, stood for something, VMA.homepage.com. And everybody, you never had to write it down. It's easy to.
Yeah. Very, very true. Very, very true. So that sign-in link should Like,
And
yeah.
that's like.
Yeah,
So we're hacking today.
Yeah.
I don't think it sent me an
No,
invite.
I
Let's
was
see
thinking
here.
about Parkland pronouncing.
I was in the meeting earlier, so I think I can just join back. Join.
I'll
Yeah,
send you some
very
money
specific.
for the pizza, yeah.
Thank you.
Before my email, right?
I don't know.
Let's find out.
Yeah. Let's see if I'm in there.
Let's say fine. How about that?
I thought you asked
Yeah.
watching you act.
Hey.
I see Charity was doing some stuff with student ambassadors.
So these aren't student ambassadors necessarily, but they are
What you want to call?
various folks from the community. So John Coleman is here.
John?
Sorry, your name again?
Courtney.
Courtney. I knew it started with a C.
Okay.
Folks, we are joined by Frank Falvey and Hal Hostedler. Hal is a 30-year Microsoft MVP, Microsoft Most Valuable Professional. And let me see, I shared my screen wrong here. Let me share my screen
The other way.
in StreamYard so you can all see us. Entire screen.
Are we gonna be sitting in the rafters?
We should
Yeah.
the main screen here once I get it up. There we go.
Okay, cool.
Slick.
So you should be able to see us all.
Yeah.
Outstanding.
Wow.
Awesome.
And where's our host? We cannot.
So our hosts are over here, but then they can see our hosts too. So Frank, Hal, and is it Mirren? Is that the other person? Frank?
Yeah, Marin just joined. I wasn't
Oh, cool.
speaking to her.
Nice. So we were working on a hackathon today, and Michael Brown put together the Juneteenth event that we held yesterday. And Michael's wearing the DeKalb hat with the brown and gold, and that has the red shirt
Where
on.
did you get that? I wonder.
And there's two Davids here. We have David, our host from Microsoft, and we have David, one of our participants.
Which one?
You and
That's John.
John. Sorry, we have two Johns. We had two of somebody. And then, sorry, your name again? Hobby. Ali. That's what I was thinking, but I wasn't 100%. And Sophia, who's on the end?
Hi, I'm Kaylee. Oh, wait.
Kaylee. Awesome. Yeah.
Hi,
There you go.
Oh, there's. Hi.
Awesome. So that's all we had to share with you all today was greetings from Chicago and the Juneteenth conference.
So could you tell the audience what the Juneteenth conference is then?
Sure. So Juneteenth is, well, actually, I'll ask if anybody else would rather explain what Juneteenth is. Any volunteers?
Okay.
Hi, team. So Juneteenth is a celebration of the anniversary of the date that the formerly enslaved Black residents of Galveston, Texas, were informed that they were no longer enslaved. The year after, in 1865, 2 years after the Emancipation Proclamation, which actually freed no slave because it only declared that they were free, but until the war ended, it was not enforced.
free slaves in the rebelling states.
Right. Also, yes. So it did.
Which were controlled by the slaveholding Confederacy.
Right.
Which is why it had
But also, yes, the
the
northern
16th
states.
Amendment should have had an effect.
But after being told they were free, they marked that day as an anniversary and celebrated in Galveston as their Independence Day, and that celebration is continued year round. And so in Juneteenth of 2020, we launched the first edition of the conference, and our mission was to highlight and celebrate Black people in technology. We had a 2-day conference that first year with over 20 speakers, and they weren't just talking about DEI. So, and the significant part of that first edition was that it was all conceived, executed, and launched in 16 days. We had coverage in Business Insider of our event, and we had over 20,000 simultaneous streamers at one point. Yeah, 13th Amendment, and so we have not had it annually since then, but we've had it. This is our 4th installment, and our second in-person event. First we were virtual. We moved to in-person in 23 here in Chicago, and we came back to Chicago for 2026, and expanded it to 2 days. The first day was the traditional conference sessions, with deep technical AI, entrepreneurship, making a path in technology, and finally today is our AI coding workshop and hackathon. So that's it in a nutshell.
Cool. Yeah, Hal was just saying they're celebrating the Tuscan Kino at the Tuscan Kino Sports Complex.
Yeah, that's it's it was set up for the Tucson farm team, for the baseball farm team, and I forget what it used to be, the Sidewinders. I'm not real sure right now, but nevertheless, that's where they're holding the local Juneteenth celebration this year. Last year, it was about 1.5 miles from me, just up one of the roads from here at a place called the Kennedy Park.
Excellent.
We walked by there later this afternoon.
Al, as soon as I told Michael your first name, he filled in the blank with your last name. Michael is a former Microsoft employee and a former MVP.
Oh yeah.
Yes, well, I apologize.
Yeah, so is the conference in every state in the US at the moment?
We don't, so the first two were the first two online,
Yeah, the first 2 were online.
and then Chicago was in person only. We didn't do hybrid in 2022.
In 23, we
23?
tried hybrid. We had a lot of technical difficulties,
Yeah.
and so
And the keynotes are on your YouTube channel.
You're not allowed to have technical difficulties. You're Microsoft.
And then this year has been primarily in person,
yeah.
but I knew about this, so I figured we'd join and make at least a component online.
Yeah, cool.
technically,
Maybe next year we might do something
Yeah,
bigger.
your channel, right?
a couple people did join. I don't know if
Maybe next year we could run something on the Azure and AI show, something a bit
it's just
bigger.
basically on YouTube. I just turn on
Yeah.
YouTube live stream.
Yeah,
So it was low
Yeah,
tech.
I'll see if I can get some of the videos or the highlights, the snippets, that type of thing. We had 5 or 6 presenters yesterday. Like 5, because we had one. Yeah, we had one. Yeah, yeah. We had a keynote at 4 p.m. yesterday.
very good. And I suppose maybe going forward we could see if we could get some student ambassadors. We could do 1 week with those if they were interested.
Yeah, yeah. So Sophia just graduated, and I don't know if that still qualifies you if you have your email from school. They've just changed some of the rules about student ambassador. And then Carol is somebody that came to visit from Texas. So Carol is visiting us from Texas, and I've mentioned this to her, Frank, too. So we may have Carol on again.
Yeah, that'd be great.
Yeah,
Very good. I've
excellent.
put out a call for speakers if anybody is interested.
Yeah, I'll definitely provide the Sessionize link too.
Yeah, I think there was a bit going on with Sessionize there that a lot of spam, people, the spam was kind of saying they were speakers and they weren't speakers.
Right.
So it's kind of messing up some of the weeks there that I might be speakers, but they mightn't be speakers as well. So,
Okay, got it.
Well, thanks, everybody. Goodbye from Chicago.
thanks, Dan.
Catch you next time.
Okay, we're nearly up on the hour anyway, and so thanks.
Everyone's saying goodbye.
And thanks to all the folks holding the celebration and keeping it alive.
Yes.
It was the best of times. It was the worst of times.
Very good. Thanks, Dan. Enjoy the rest of the day. So Hal, we're up on nearly up on the hour anyway. Marion, can you hear me? Have you anything for us or any questions? No. Okay, so Hal, we filled up another hour of it.
Outstanding.
Very good. And if you have anything for us any week, just pop me a note beforehand and we'll keep a slot for you.
Okay, sounds like well, I'm going to be here anyway, so as long as you send me a link, I will show up.
Very good. I normally post a link in the Azure and AI message board anyway.
Yep.
And I posted a few things for call for speakers in a few different places. If anybody is listening and they want to speak on the Azure and AI show, message me up on LinkedIn, and I'll be happy to share links with you to I'll actually just put it up on the screen there as well. 1 second now before we finish up. 2 seconds now. It's One second now, I'll just put a banner up on the bottom. And okay. Yeah, so
There
it's
we go.
coming along the bottom there. So just go into sessionize.com/, the Azure underscore Azure and AI show. So if you go into sessionizeanyway.com and you can find call for speakers and you find the Azure and AI show and sign up there and we'll be in contact. So thanks everyone for joining us. We'll be back here again next week at the same time,
With bells on.
7 p.m. Irish time. And Hal, what time is it in the States now?
Right now is just a few minutes after noon.
Okay.
Again,
very good.
that's
11 a.m. it starts, is it? 11 a.m. in Arizona.
that's Mountain. Yeah, Arizona never changes. It doesn't subscribe to daylight savings time. We get
Okay.
enough sunlight. We could export some.
Okay. Thanks, guys.
You
Bye-bye.
bet.